In this video, I'm going to go through a couple of examples using Pascal's triangle. The first question says, in the expansion of negative 3x plus 4y exponent 6, we have to determine the value of k if the term is kx exponent 5 times y. First of all, we know that we have to use the Pascal's triangle. So I'm going to expand Pascal's triangle for 6 rows. So this is n equal to 0 for Pascal's triangle. Then you have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, then 1, 5, 10, 10, 5, 1. I need one more row, and that's 1, 6, 15, 20, 15, 6, 1. Now, since the first term, which is a is negative 3x, and b is 4y, since in this term x is exponent 5, and if you remember the previous video, we said that a starts with the maximum exponent, which is 6, then it goes to x exponent 5. So if I really represent the expansion, the second term of the expansion is going to be negative 3x exponent 5 and then 4y exponent 1. And then I'm going to have a coefficient here, which is going to be the second term here, which is 6. So to find k, I just have to find what exactly is the product of all these numbers. So k is going to be 6 times negative 3 exponent 5 times 4 exponent 1. If you use your calculator and evaluate this one, then we are going to find that k is equal to negative 5832. So this is the first one. The next question is, if I expanded negative 3x plus 4y exponent 6, what is the value of k and m in this term here? First of all, I know that the sum of the exponents of x and y has to be equal to 6. So this means that m plus 1, because exponent of x is 1, has to be equal to 6. So from here I get that m is 6 minus 1, which is 5. So we get kxy exponent 5. To have kxy exponent 5, this means that b has to have exponent 5. And remember that in our expansion, a was negative 3x, b was 4y. So this means that I have to find k for the following expression. First, negative 3x exponent 1 and 4y exponent 5. And then I'm going to have a coefficient here, since y is exponent 5 here. Remember, x here is the maximum, which is 6, then 5, then 4, then 3, then 2, then 1. So this is the coefficient. So I have to find 6 times negative 3x exponent 1, 4y exponent 5. So I have to evaluate this expression to find k. And if you use your calculator and evaluate this one, you get negative 18,432. So k is negative 18,432. The next question is, find k and m if the term is ky exponent m. Since x is not there, really I can write this term as kx exponent 0 y exponent m. Now, this means the only possibility for m is when the sum m plus 0 has to be equal to 6, then it means that m is equal to 6. That's the first thing. The other thing is that since x is exponent 0, this means that this is the coefficient that I'm looking for. Remember, x has exponent 6 here, then 5, then 4, 3, 2, 1, and then exponent of x is 0 here. This is the coefficient. So this means I have to evaluate 1 times negative 3x exponent 0, and y is 4y, b is 4y exponent m, which is 6. So I have to evaluate this expression. This one gives me 1. 1 times 1 is 1. So k is 4 exponent 6, which is equal to 4096. The next example, the term is kx exponent 3 y exponent m plus 1. Again, 3 plus m plus 1 has to be equal to 6. So this becomes m plus 4 is 6. So m is 6 minus 4, which is 2. So we have to find now kx exponent 3 y exponent 3. Now again we are going to go through the terms here. This is x exponent 6, 5, 4, 3. This is the one that we are concerned with. So if we expand it, then we're going to get 20, but our a value is negative 3x, so it's going to be exponent 3, and y value is 4y, which is going to be exponent 3. If you find 20 times negative 3 exponent 3, 4 exponent 3, this is going to be the value of k, and the value of k becomes negative 34,560. The next question is a word problem. It says a new car is valued at 142,000. The annual depreciation rate, meaning how much the value decreases, is 11.5%, which is 0.115. Make a table of values to show the value of the car over the first 5 years. So I'm going to have a table of values like this one. T starts from 0, 1, 2, 3, 4, 5, and V is the value of the car. When you buy the car, it's $142,000. Now, at the beginning of the first year after you bought the car, the value becomes 142,000 minus 11.5%. It goes down, so it's going to be 0.115 times 142,000. That's going to be the value of the car, which is going to be 125,670. The next year is going to be 125,670 minus 0.115 times 125,670. Again, another 11.5% goes down. This becomes 117.95. If you continue with this process, you get the next year is 98,427.89. The next one is 87,108.68. And the fifth year is going to be 77,091.18. The next question says, determine an explicit formula in function notation to model the value of the car in year n. This means I have to find a formula for V of n in terms of n, the number of years. I know initially the value was 142,000, so it's 142,000 times. Now, the value depreciates when it starts is 100%, then every year it goes down by 11.5%, so it's going to be 1 minus 0.115 exponent n, which is going to be 142,000 times 0.885 exponent n. The next question says, what is the value of the car after 13 years? Using the formula we found in B, we say that V of 13 is 142,000 times 0.885 exponent 13. This approximately becomes $29,010.21.